Hi, Calculus 1 students. So this is the only related rate problem you have to watch on YouTube. Okay, the rest we will have covered in class. Although that might change, I hope not. But if I tell you otherwise, you might have other videos to watch. That being said, this is a first of all, it's an important example. Like I cannot cover them all in class, unfortunately, but it's important that you do like specific types of examples at least once. And I'm gonna make sure that like they show up all in your assignment. So here's this one. I call this a shadow problem, and they will all be solved in similar ways. I say similar, not exactly the same, but using the same kind of ideas. A bright spotlight illuminates a field from a height of 10 meters. Okay, so we have a beautiful drawing over here. Okay, but that's it. So you have to kind of come up with that. You have to be ready to come up with that type of drawing. That being said, in this final exam, it was given, okay, because we didn't want too much students to lose mark because they could not picture the situation. So from a height of 10 meters, you have a spotlight. 8 meters away, like on the ground from the spotlight, pretty much. That's what is written over there. Then Jack throws a tennis ball vertically, like just like upside, like that's it, vertically, and observes the ball's shadow because the light is gonna illuminate the ball and create a shadow. And he observes the way the shadow moves. Okay, and when the ball reaches a height of 6 meters, its speed is 7 meters per second. Okay, at that instant, how fast does the ball's shadow move on the ground? Okay, the first thing I'm going to do is I'm going to show you exactly what not to do. Okay, so on this diagram, I know a lot of students will be tempted to write here 6 meters and here 7 meters per second. Okay, don't do that. Okay, the reason is because this 8 meter and this 10 meters are actually constants. Okay, so what you have to do instead, so I will keep these like crossed X even if they don't look pretty, just to really emphasize, do not label your 6 meters and your 7 meters per second here because they are changing, because they are not constant, unlike the 8 meters and the 10 meters. What you have to do instead is to write variables for them. So for example, I'm gonna call this y. It's very appealing because like in physics, I guess you're used of saying y to be like the vertical coordinate. I think sometimes you call it h, but I think like even my physics teacher were using y. So this is appealing. And then this arrow over here, we're gonna write instead of 7 meters per second, we're gonna write that it's dy over dt. Okay, in other words, we're going to replace it by 7 meters per second only at the very end when we find the relationship, when we find the related rate between, that's it, like the y and the x. Speaking of x, what is x, right? Okay, so we need to create a variable that describes the position of the shadow. And from what I see, the most convenient one I would use would be, and I will color code it in orange, will be actually the entire length, okay, including the 8. I'm not sure it's actually not sure. Oh, well, okay, let's try. It's not important, okay? What you have to realize is that you could also pick this small length over here. It would work as well. But to be safe, I prefer x to be like that's it, the full distance. I don't think it will change much of a thing, but maybe. And then this arrow over here, which represents kind of the velocity of the shadow, the speed of the shadow, we're going to call it dx over dt. And this is what we are looking for. Okay? So the most important thing is to have a proper setup, right? What are constants? You write with numbers. What are variables? You write with Like that's it, y and dy over dt, x and dx over dt. So now what we want to do is to find a relationship. Oh, by the way, this is step number 1. So what I did over here, step number 1, set up. Okay? Step number 2, once that is done, is to find a relationship between x and y. Because we have the rate of y, we want to find the rate of x. Let's write it down. So we have dy over dt, right? dy over dt. Okay? We want to find the x over dt. Dx over dt. Okay? A lot of students skip that step of writing down what they have and what they want to find. It's up to you guys, but I recommend that you write it. And the reason for it is because it's going to make it clear that you want to relate x and y. So relate x, or let's put it this way, relate y and x. Okay. And now you have to be very careful about the relationship that you're using to relate y and x. For a very good reason is you have to make optimal use of the constants that you have. So this problem appeared in the final exam, and I was a teacher back then. So I remember how my students did on that problem. And one of the mistakes that they did often is that they were using the Pythagorean formula. They were seeing this, oh, we have a right triangle. Let's use the Pythagorean formula. And the reason why it's not a good idea is that, okay, so y and x are both variables, but it turns out that this hypotenuse is also a variable. So in other words, if you use the Pythagorean formula, you're not really relating x and y because you have a third, like, undesired variable to deal with. So instead, it's important to realize that what you have here are similar triangles. And let's actually redraw the setup like just a little bit in order to show it to you. Okay, so we have like here this 10 meters, and we have here this like, let's not draw the 8. I think it's, oh no, let's draw the 8. So here, let's have this. Okay, I have a little bit of trouble to draw this. Now, okay. So we know that the full side here is x. So this whole thing, we know that this is x. And we also know that this side right here, and I don't have a lot of colors left, so I'm going to color code it in purple. We know that this side over here is x minus 8, okay? The 8 that is actually here. And this side over here turns out to be y, okay? And what is to realize is that the black triangle is similar to the red triangle that we have over here. Okay? So that's it. We have two similar triangles. And what does it mean? It means that the ratio of their lengths, in other words, if you want to see it this way, the tangent of this angle will be y over x minus 8, but will also be 10 over x. So the corresponding ratios of lengths are equal. Ratios of lengths are equal. Okay? So now that we have it, I will erase the entire problem. Should I? No, okay, let's not erase the problem. We will try to work with small space. So what it means, and fortunately I'll be able to erase the diagram right after, is that 10 divided by x, so 10 over x, okay, and as I can see, I need to change my orange. So 10 divided by x will be equal to y divided by x minus 8. And actually, yeah. Oh, yeah, the 10 is here, and this is over x minus 8. Okay. Although you could differentiate it right away, I would highly suggest that you simplify it as much as you can. Okay, and don't forget here that what you're looking for is actually x prime. Okay, dx over dt. That's what you're looking for. So keep that in mind when you want to replace, whenever you want to simplify this equation. So the first thing I would do here is cross multiply. So I would have like 10 times x minus 8 would have to be equal x times y. All right, and let's actually bring all the x's together and factor x out in order to single it out. That will help. Okay, so what does it mean? It means that we have like 10x minus 80 is equal to xy. But then and actually I'm going to write it here instead. So that's it, 10x minus 80 is equal to xy. And from there, what it means is we're sending x on the other side. So we have like 10x minus xy is equal to 80, which means, so factoring x out, we will finally get x times 10 minus y is equal to 80. Okay, and from there, this is the best type of formula we can have for implicit differentiation. So remember, this is step number 2. Now it's done. Step number 3, I'm going to erase this. And let's actually recall what step number 3 is to differentiate implicitly in T, okay? And I would highly recommend here the Leibniz notation because you won't do any mistake if you take it. Taking Lagrange notation is tricky because like the derivative of x is not simply 1. It's going to be x prime, okay? So be careful about that. So here, the derivative of x is going to be dx over dt. Heads up, we're using the product rule, okay? So the derivative of the first times the second, so 10 minus y, plus the first times the derivative of the second, which ends up simply being negative dy over dt. And then the derivative of 80 is simply 0, okay? Now, from there, you simply solve for dx over dt. There's more than one way to do it, but I think what I will do is I would solve directly for dx over dt. So let's actually write this, solve for dx over dt. Okay, and as you can see, it's not going to be long because we're going to get in the end 1 over 10 minus y multiplied by x dy over dt. So this step, I encourage you to try it out by yourself. Like, just make sure that you get that. And just for readability, I will put the x here on top. But there you go. By solving it, you're going to have this. And the last step is obviously to replace by the data we have. So replace in the data. So from there, we have that dx over dt will be equal to, so the current value of x, now unfortunately we don't have it, but we could figure it out, okay? So let's actually do it. So when y is equal to 6, y is equal to 6, we have that 10 divided by x, so 10 divided by x, and we don't know what x is, remember, that's what we want to figure out, is equal to 6 times over x minus 8. And it was the relationship in purple, if I recall correctly. X minus 8. So, like, actually, I could have used the relationship that's already solved for, but unfortunately, I'm going to have to kind of do it again because I don't remember exactly what I had. But yeah, so in other words, you're going to get here 10x minus 80 is equal to 6x. And then from there, obviously, 4x is equal to 80, meaning that x is equal to 20. Okay? Let's color code this in orange. We're going to make use of it. So as a consequence, we have that dx over dt, which is what we're looking for, is equal to 20, the number that we just found, over y, 10 minus y. So 10 minus 6. Okay? And that is multiplied by dy over dt, which at this point we have, right? It is the 7 meters per second. Actually, why did I color code this in red? Okay, well, it doesn't really matter. Okay, so this is what you have for y, and this is what you have for dy over dt. So it is multiplied by 7 meters per second, and of course you have to grind the coffee. Okay, so it's gonna end up being to 35 meters per second, which is your final answer. All right. I'm sorry for the time it took to do this video, but I think pretty much all what I said was crucial. So a related rate problem is not, typically it's short to do, but it's long to explain. So that's why the video is so long. So sorry about that, but hopefully this really helped. See you in class or in the next video.